Hi everyone, we are finally on the last video for section 3.1 and 3.2. So in this last video, we're just going to talk about properties of addition. So these are found on page 76. So these are all different properties of addition. And so let's go through them, right? So the commutative property just deals with the order that we add numbers in. So this essentially says that if you add A and B, that's the same thing as adding B and A. It doesn't matter what order we add numbers in, we get the same result. The associative property deals with when we add more than two numbers. It says that if we're adding three numbers, we can add the first two and then the third one, and that's the exact same thing as adding the last two and then the first one, right? Following these parentheses. So in addition to the commutative property in which it doesn't matter what order we do things in, the associative property, it also doesn't matter what order we do things in. So it just makes everything a lot simpler. So the next thing is the additive identity. So the additive identity is a number that when added to any other number, you get the same thing. So for the real numbers, we get 0, right? So 0 plus anything just gives us that number back. So that is the additive identity property that the additive identity will always have. And this is saying additive because when we add it, nothing happens. Everything stays the same. Everything is identical to before we did the operation. So yeah, so one thing to note is that these all say real numbers, even though, right, we're only dealing with whole numbers in this chapter. These properties are going to be the same for addition of all of the numbers. So these definitions will keep coming up as we go through the whole numbers, the natural numbers, the integers, the rationals, and the reals. So all of these are the exact same throughout. So what's really nice about these properties is that they just make doing math really nice because we don't have to worry about the order that things occur, right? We can just go through it. And so that just makes it easy. Like when we talked about the properties of equality, right? We had the reflexive, symmetric, and transitive property of equality, make it really nice so that we don't have to think as hard about the things that we do and the order that things happen. So these are other properties that make the math that we do really, really nice. So where are these properties used? So first off, the commutative property is really useful in these addition tables. So we have these addition tables, right, just like our multiplication tables, where we can see things like this, where we can look at 3, and we can look at the 3 column and the 9 row, and we can look and find that 9 plus 3 right here is 12. So we can look at that and see that 9 plus 3 is 12. Okay, but because we have this commutative property, we also know that 3 plus 9 is the exact same thing. It doesn't change. So if we start here at 3 and go over, whoops. So if we start here at 3 and go over, and then at 9, this right here should be 12. So these tables will mirror each other, right? Right over this blue line, it'll mirror the different addition facts that we have. So that's where we can use the commutative property. So the next property was association. So this is really useful for when we do things. So commutative property. This is helpful for addition tables. So now the associative property. This is really useful for mental math. So for example, if we were doing 35 plus 8, well, we know that that's equal to 35 plus, and then 8 is 5 plus 3. And so because we can reassociate our addition, we can now do 35 plus 5 plus 3. And 35 plus 5 is a lot easier to do, if we know our multiples of 5. So this becomes 40 plus 3, which is 43. So if you didn't for a lot of people, it's easier to add multiples of 5 together and just increase to the next multiple of 5 rather than knowing that 5 plus 8 is 13 and then adding that to 30. So people do this all the time, even when you know, right? We all know how to add these numbers. This is just quicker for a lot of people to deal with multiples of 5 and 10 and so on. So now where do we use the identity? So the identity is used actually in that last algorithm that we talked about. So when we had this Austrian algorithm, we had that here, we had 10, right? We added 10 and did 10 minus 7. Well, that's the same thing as here, we did 1 minus 1 minus 6. So we added 10 to 0, right? We added 10 to 0 here, and then we subtracted it here because those are the same thing. Because we know that 10 and negative 10 together is the same thing as adding 0. And similarly here, we added 10 to get 11, but then we subtracted it here. So the identity, we use it to simplify that we can add and subtract the same thing. So when we add and subtract the same thing, this doesn't change. Doesn't change the problem. Because when we add and subtract the same thing, it's essentially the same as adding 0, and it doesn't change it, right? The value stays the same because 0 has this additive identity property where adding 0 doesn't change anything. So now let's talk about, do any of these properties hold for subtraction? So all of this so far has been properties of addition. So let's talk about if these hold for subtraction. So let's just take an example. So subtraction, let's look at commutativity. So the commutative property is also called commutativity. The associative property is also called associativity, right? It has that property. So let's just take an example. So let's look at, for subtraction, let's look at 3 minus 2. Well, we know that that's 1. So what happens if we switch the 2 and the 3? We're looking at 2 minus 3 equals minus 1. Well, those are not the same. And even here, we're trying to deal with whole numbers, right? We haven't gotten to the natural numbers, nor have we gotten to the integers where we could consider things like minus 1 that have those negative numbers. So these things are not the same, right? If we just switch the 2 and the 3, right, we're switching those whole numbers around, right? The whole numbers are positive, they don't include 0. So when we switch those whole numbers around, we don't get the same answer. So this is not commutative because of this example. So now let's look at associative. Okay, so again, let's just take another simple example. Let's look at 3 minus 2 minus 1. So that is going to be 3 minus 2 is 1, and we subtract 1, well, we're going to get 0. And now let's look at 3 minus 2 minus 1. Well, 2 minus 1 is 1, so we're going to look at 3 minus 1, and that's 2. So again, these are not the same. So we have that this is not an associative operation. So lastly, let's look at an identity. Well, we know that whenever we take a number, let's say A, and we subtract 0, well, if we were doing this on our base block model, if we take away 0, then we don't take away anything. We just leave the blocks exactly like they were. If we were doing this on a number line, we wouldn't go back any spaces to take anything away. So we know that this just leaves the number the same. However, if we look at that and we switch them, right? Remember, the identity works both ways up here, right? We have that when you add 0 in the second position and when you add 0 in the first position, it stays the same. So in order to be this identity, it needs to be the same in both positions. But when we do 0 minus A, that's not A, right? And when we're dealing with whole numbers, we can't even take a away from 0. This is the case where we would need to borrow, and we can't even do that here. So again, these are not the same. And 0 is not an identity for subtraction. So yeah, none of these properties hold for subtraction. We don't have that it's commutative or associative, and it doesn't have an identity. Because if it did have an identity, so this a minus 0 being a, this right here is what we call a right-hand identity. Because when we subtract 0, when we do the operation with 0 on the right here we're subtracting 0 on the right. In that case, we do have an identity, right? It works when we have 0 on the right, but when we have 0 on the left, it doesn't work anymore. So